Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. In this module, we are going to look at a few case studies and see how the various theories that we have been studying have been implemented in practice. So, the learning objectives of today's module will be, we will look at the open source cloud platform which is called the OpenStack. We will look at the OpenStack in details, because OpenStack is a very important cloud mechanism that is being used extensively in the industry as well as the academia. We will look at the services of OpenStack and the properties of OpenStack, and then we will look at another open source platform which is called the Eucalyptus, because this is the oldest platform that was developed as open source cloud platform. So, we will take a quick look at that, and one more concept that has been taken up, that is coming up very properly, is the containers, and we will see how containers are being used in a cloud environment. So, this OpenStack is actually not a tool, it is more like a project. It is a collection of many open source projects, and it contains a set of interrelated components which are put together, are called a cloud infrastructure OpenStack. It is actually globally collaborated and developed by many developers and many professionals. So, what is OpenStack? It is actually a cloud operating system which offers a cloud environment. When installed and instantiated, it offers a cloud platform to the it generates VM and offers a cloud platform. Largely it is used for infrastructure as a service cloud, but it can also be used as PaaS. That is what the OpenStack is meant for. There will be some core services and there will be some optional services. Very often they will release the optional services. So, the software platform consists of interrelated components that have the control. The hardware pool, which will be a multi-vector hardware pool of containing processing units, containing storage, and the networking components which will connect the processing units and the storages will be taken up by the OpenStack and will be converted to a data center. So, the principles, as part of principles, we will look at the OpenStack mission, the design and development process, and the open community, because it is very unique the way OpenStack is being developed. That is why we need to look at that. This is the OpenStack mission, and therefore, it is a open source, openly designed, openly developed by an open community software. So, how the design and development process happens, it is a very unique process, as we have mentioned. Every 6 months there will be open summits, which is free for anybody who wants to join, and professionals all over the globe will join these open summits to decide the next development of the OpenStack. Then the code, whatever will be developed, comes under the Apache 2.0 license, and it will be freely available to anybody who wants to use it. And anyone who wants to develop some code are allowed to develop, but inclusion of that will be decided by the core committee. So, the code will be reviewed and roadmaps will be discussed. These are all public information, publicly available and publicly implemented. So, the OpenStack community also is a very large, vibrant community, active people. They are all either developing or using OpenStack. All processes will be documented and they will be open and transparently developed. So, this is another interesting fact on OpenStack. At the releases, they started with the release of Austin, and then they progressed through the various names, and as we can see that each name is actually the next letter in the alphabet, and this continues. Currently the latest release is the Newton, which was released in last year 2016, and the next release is already got its name, it is Okata, and that is being released. Now, the names came from names are generated or created based on some locality where the summit has been held, the Open Summit has been held, or sometimes it will be some speciality of that location, but it is related to the locality where the summit is being held. Now, let us look at the projects. There are 6 core projects which are necessary part of OpenStack, without which the OpenStack cannot be implemented, and there are 13 optional projects or services. The number of these optional services will keep on increasing as users and developers feel something is needed. They add to the OpenStack code, and this code is reviewed and included in the OpenStack environment if found correct. So, OpenStack is not a hypervisor on its own. It does not have a hypervisor, it does not come bundled with a hypervisor. So, we need to install a hypervisor separately. Therefore, OpenStack needs to support certain hypervisors, and it supports multiple hypervisors. It supports KVM, it supports KMU, it supports Zen paravirtualization, it supports vSphere from VMware, and so on. It supports so many different hypervisors, any one based on our requirement we can choose. Now, we talked so much about communication. How communication happens in OpenStack? There are 2 ways that the entities in an OpenStack environment can communicate with each other. The first is through RPC and through a message queue environment. So, remote procedure call or RPC is a major distributed mechanism that we looked at. OpenStack uses RPC for mechanism. The other one is dependent on the web service communication architecture, since it is fully REST based. So, it uses web server gateway interface for communication. So, certain parts, internal parts communicate using the RPC and messaging queue environment, other parts communicate using the through the REST API. So, there will be the databases in the back end, and there will be other libraries which need to communicate with each other. Large amount of communication happens. The hypervisors, how the hypervisor will communicate will depend on the hypervisor that is of our choice. Actually, interestingly, almost 75% or little less 70% of the users choose KVM as the hypervisor because of the ease of use and its quick requirement is easy requirement for implementation. So, these are the 6 core services that we are using in OpenStack. The first one is the Nova. This is the main central core service. This is the compute node, and then we have Swift, which is the object storage. Then we have Cinder, which is a block storage. Then we have Neutron, which is the networking mechanism. Then we have Glance, which is the image service, and finally we have Keystone, which is the which provides the privacy and security. So, what is the job of Nova? It manages the virtual machines. So, virtual machines will be created, will be used, will be spent its time, its life cycle in the environment and will be terminated. That whole process is taken care of by the compute service, which is the NOVA. It creates an automatic pool of resources, and this is also the main part of the IaaS system. This is the fabric or the framework on which the IaaS system will be built or developed. What are the specific functionalities? It spawns a new VM, it schedules the VMs, it starts a VM, it stops a VM, which is commissioning and decommissioning on demand. The next one, so I have the virtual machine. So OpenStack has the virtualizer, hypervisor or VMM, which helps communicate to the lower layer, which is the operating system, the base operating system, and on top of this NOVA runs, which creates the virtual machines. Now, these virtual machines need to communicate with each other, and that is done through networking, that is the neutron part. Owns, manages and controls the network of the VMs and the hosts in cloud, manages the IP addresses of the virtual machines. Depending on the host IP address, it will manage the IP address of the virtual machines where they are running. Routes and controls traffic within the host, and provides advanced networking functionalities like SDN. OpenStack does support NFV and SDN, and that is the networking virtualization that is supported by OpenStack. It provides an API and framework for extending the functionalities, just like we saw in our network virtualization module. Storage in OpenStack, the default storage is ephemeral, which means that it will continue, it's dependent, it's tied to the VM, and therefore it will last as long as the VM lasts. There are 3 persistent storages. These persistent storages are not dependent on the instance that are running or the data that has been generated by the by any instance. They outlive the other resources and are always available. These are 3 types. One is the block level, one is the object level, and one is the file level. All 3 are available in OpenStack. Swift is the object store. This is the object level storage that we are talking about. This uses the distributed architecture. There is no central point of control, and it uses a RESTful architecture based on HTTP based API. Then Cinder, which is the block storage, when a particular application wants some sensitive is a sensitive, store sensitive or data sensitive operation, then we can have additional block level storages connected to the VM through this particular project called service called Cinder. This is a pluggable architecture where external storage devices can be plugged in and can be used in terms of block level storage. It supports snapshot mechanism. We have learned extensively how snapshot is used for storing and saving, ensuring the safety of an environment, and OpenStack uses snapshot, and any sensitive scenario, any invaluable data can be stored using this extended storage mechanism. Keystone is the identity service. We have learned how the identity mechanism can be, identity management can be used for security of the environment, and OpenStack supports that through this service called Keystone. It will be a role based access control. So, role based access control is implemented. Even the earlier mechanisms like LDAP also, LDAP also is used by this. It supports multiple forms of authentication, and one or many, a combination can be used. Glance is the imaging service. Now, in a virtual environment, the VMs are nothing but images of what are the requirements of the users. So, storing such images is very useful in terms of reuse, in terms of continuity, in terms of stopping a service and restarting once more. So, that is what Glance does. Glance stores the images, and so an image created can be stored in Glance and can be retrieved back. So, for backup is very good. Even as a template, I created something and I want to refer to that for the next VM, or I want exactly a copy of that VM, is easily available because of the imaging service Glance. Now, these are the other additional services that are available. We will talk about one particular additional service, which is the dashboard service, which is called the Horizon. This provides the mechanism of interfacing across all the parts that are there, all the resources. Administrators and users both can interact with each other, and they can interact with the OpenStack components through a dashboard through Horizon, and it has the specific API using which the communication. So, this is the OpenStack essential service model. Whenever we look at OpenStack, this is the diagram that comes. So, these are the compute, storage and compute, networking and storage 3 services, and these are the rest are all shared services on top which these services are there, and they can be communicated through the dashboard Horizon, and all applications can connect to it. So, that is how. So, what are the properties? Load balancing, it's highly load balanced, it's highly fault tolerant, it's highly available. We will talk about the high availability. It's highly secured, security is very high using Keystone and identity management. It's highly compatible since it's web service based. So, therefore, it is very compatible with many other services. So, how high availability in OpenStack? By replication. By replicating, everything can be replicated in OpenStack, and therefore, high availability OpenStack can be implemented. The RabbitMQ, which is the messaging service, can also be replicated, therefore, ensuring communication. Further, the disk level replication in MySQL, networking and Horizon in replication, and predicting failure, thereby ensuring that everything is highly available. And the federated identity ensures that security is maintained. This is a mechanism which establishes trust. It is something that we have studied. It is identical to what we have studied in our security module. Federation in OpenStack is also available. As we have learned in our in one of the earlier modules, that cloud federation is becoming very popular nowadays. So, if we take 2 OpenStack based cloud, then because they are similar at every level, federating between these OpenStack cloud is easy and it is available. How do I deploy OpenStack? I can deploy it in one single virtual machine of some environment. I can deploy it in one single physical machine, or I can deploy it in a distributed multiple node environment, the controlling compute and the storage clusters, both for high availability, that is HA, and disaster recovery, that is DR. So, these are the hardware and software requirements, and there are 2 ways that OpenStack can be installed. One is from the source code, which is more difficult, and other is the dev stack, which is the binaries. And OpenStack Foundation is a large fast growing foundation, and anybody can become a member of this community. These are some of the resources. Next, we talk about Eucalyptus, which was the perhaps the earliest open source resource that has come in. This builds from AWS, and it is compatible for creating both private and hybrid cloud, and is Linux based. The name is given from these words, which is Elastic Utility Computing Architecture, linking your programs to useful systems, or Eucalyptus. And these are the generic components of eucalyptus. Next we come to the to a very pertinent part of our current day mechanisms, tools that are available. They are called containers. During virtualization discussion, we talked about OS virtualization, that is the containerization of our environment. So, OS level virtualization generally creates a container rather than creating a virtual machine, which is the server level virtualization, and these containers hold the whole environment. So, this is an alternative to virtual machines. These are portable environment to run applications along with the necessary libraries and dependencies. So, they offer streamlined, secure, easily deployable method to implement an infrastructure. The virtual applications provide a single instance of application. They virtualize by providing a single instance, and it creates an isolation boundary at application level rather than at the infrastructure level. So, when we go for a server virtualization, we create the infrastructure, we take pieces of infrastructure and put them together to create a virtual machine. In case of a container, it is the boundary of the application without really much worrying about the resources that are made available. So, a VM has specific amount of resource, a container has a specific application or a set of applications that will run inside the inside this box. This is the OS level virtualization without launching an entire VM for each application. So, what are the different types of containers? There are two types of containers, system container and application container. In a system container, that is the entire system, the OS, application services, etc., can exist in one container. So, these are bigger containers which contains or allows many components to reside together, and so this is more like a virtual machine which has its own operating system, its own hardware components and its application, etc. The application containers are the way to bundle and run applications in a more portable way. So, when we have a number of applications that need to run together, we can create a container and run that. If an application is not to run completely in one environment, then we can use an application container and we can split the application into smaller parts and we can run them in separate containers. That is possible. Whereas, if we compare this to a virtual machine, this kind of mechanism is not possible. If I create a virtual machine, then virtual machine, as the name suggests, is more like a physical machine. In one physical machine, I need to run one application if that application is meant to be run in a single machine. So, virtual machine is a smaller a prototype kind of thing for an overall machine, and we can take one application and run it completely in that virtual machine. Whereas, when we take an application container, we can distribute our application in different containers created for this purpose. So, what is the benefit of having a container? It is portable. Once containers are created, it can be deployed to different servers. So, from one server it can be easily ported to other servers. It generates an isolated environment. So, if I deploy two applications or two parts of the application in two containers, then they are not they do not affect each other. Compatibility problem does not exist further when we are containerizing it. It does not need full operating systems to be installed or a virtual copy of the server's hardware. Limited resource requirements, it is able to take very limited amount of resource. It is much cheaper when we compare a virtual machine which has to be given a complete operating system and a complete environment full with its storage and its computation, its processor, etc., which is not the case for a container, and it is a lightweight environment. So, if we compare a container with a virtual machine is a more heavyweight part of counterpart of container. Virtual machine is therefore little easier to maintain because it is a complete machine and some patches can be generated, whereas difficult to manage containers are more difficult to manage when there are many containers. Each container will have separate requirements, but they will be combined together. All containers on the same host share the same OS kernel. So, it becomes very difficult for the kernel to manage these applications and keep them separate from each other. So, therefore, the basic fundamental tenet on which the containerization is beneficial, maintaining that becomes difficult because it it generates the communication, it makes the communication difficult for the OS, whereas that same problem does not exist in a VM, because VM is complete with its own operating system and its own resources. A container does not load a OS, so therefore, it is faster, whereas VM has to wait for an operating system for its own operating system to load. So, therefore, it is a slower mechanism, and the kernel is abstracted in case of a container. Virtual machine abstracts actually the whole machine, whole device is abstracted. So, Docker is an example of providing containers. They are the company which provides containers. They are widely employed container management engine. Piece of software in a complete file system. It contains the application code, runtime, system tools, etc., and guarantees that the software will run. It is lightweight, open standards accelerate the development, and it eliminates environment inconsistencies, and it is an agile portable control. So, in OpenStack containers are supported. It supports all the possible engines. Docker, Kubernetes and Apache Mesos are the different engines that are supported. It orchestrates among the containers using one of the optional additional services called Heat, and this orchestration framework allows the containers to be put together for some benefit. The additional containers in OpenStack are the services are called Magnum. This is a project in OpenStack. Cola is not yet integrated with OpenStack as of now, but that is also a container service, and Murano is an integrated service. So, to summarize this module, we have looked at 3 case studies. We looked at extensively at OpenStack, and we understood what are the concepts that have been used in OpenStack. We looked at the very early implementation of an open source environment called Eucalyptus, and we looked at most recent open source implementations, which are containers. These are our references. Thank you.